I've done quite a bit of programming, and so I've developed some sound editing software. And by and large, that's been really quite separate from my mathematical interests. But at least once there was really an overlap of the two, which is that like back in the late 90s or mid 90s or something like that, when I started to write that processing software, I became aware of wavelets as a tool for digital signal processing, purely from a kind of engineering point of view, if you want. So what I was interested in at the time, in terms of application to the sound editing software, was to develop an algorithm for removing background noise from a recording. And I was thinking about using wavelets for that. I never really did it in the end, but I sort of looked up wavelets at the time. And then much later, so like almost 20 years later, I was working on some problem in stochastic PDEs, basically trying to give meaning to solutions to some ill-posed equations. And there's one kind of technical result that had been obtained in a somewhat related but different context, but which was very much a one-dimensional kind of result. And I was thinking about what should be the correct higher dimensional analog of that result. And then at some point I kind of had that flash in my mind as I thought back about the wavelets and about properties of wavelets, and realized that they were actually useful there. And of course, I knew that wavelets had also been used as an analytical tool for proving theorems and in real analysis. But it was always kind of quite far from what I was doing mathematically. So I really knew them only from the signal processing side. But it turned out that it was really the right tool. It was a very helpful tool, and it kind of really worked out. And I don't think that if I didn't have that kind of experience from signal processing, which in principle is really quite far from pure mathematics, I don't think I would have ever thought about it, actually.